Chapter 9 Applications of Integration Exercise 9.3 Question 2 Division number 9. The question is evaluate integral 0 to pi x sin x divided by 1 plus sin x dx. Solution. First take our given integral as I. I is equal to integral 0 to pi x sin x divided by 1 plus sin x dx. Take this is a number 1 equation. Number 1 equation. We know one property. The property is integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. The property is an important property. Integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Here our a is pi, therefore a minus x takes pi minus x. Therefore our integral I is equal to integral 0 to pi. This every x is replaced by a minus x. Every x is replaced by a minus x. Therefore, this x takes pi minus x. So, pi minus x and sin pi minus x divided by 1 plus sin pi minus x into dx. This is equal to integral 0 to pi minus x. We know that sin of pi minus x equal to sin x. Therefore, for that term we can substitute sin x divided by 1 plus sin x dx. Note that it is a number 2 equation. So, before applying the property, our I is number 1. After applying the property, our I is equal to take number 2 equation. Now, adding 1 and 2. In left side, I plus I. That is equal to the right hand side, the first term is integral 0 to pi x sin x divided by 1 plus sin x dx plus integral 0 to pi minus x sin x divided by 1 plus sin x into dx. Here the both integral limits are same, 0 to pi, here also 0 to pi. Therefore, write as a common integral 0 to pi. And denominator also same, that is the denominator is 1 plus sin x. Just add the numerator x sin x plus pi minus x sin x into dx. This is equal to integral 0 to pi. Integral 0 to pi is divided by 1 plus sin x, x sin x, in numerator x sin x. This sin x is multiplied inside the bracket, we get pi sin x minus x sin x into dx. This x sin x and minus x sin x get cancelled. The remaining terms, integral 0 to pi sin x divided by 1 plus sin x dx. Here pi is a constant, take outside. So, pi integral 0 to pi sin x 1 plus sin x. This term is multiplied with 1 minus sin x in numerator and multiplied 1 minus sin x in denominator. Denominator left side is I plus I is a 2i. So, 2i is equal to this term. Here looking at the denominator, it is of the form a plus b, a minus b, that is equal to, we know that it is a square minus b square. we know that it is a square minus b square. Therefore, our 2i is equal to our 2i is equal to integral 0 to 2i is equal to pi integral 0 to pi. The numerator is sin x 1 minus sin x is divided by a square 1 square minus sin square x into dx. This is equal to pi integral 0 to pi. This sin x is multiplied inside the bracket. We get sin x minus sin square x divided by cos square x. 1 minus sin square is a cos square x dx. And this term is equal to pi in numerator 2 terms. Therefore, separate 2 integrals. So, pi 0 to pi sin x by cos square x dx minus this pi is common for both integral. Therefore, integral 0 to pi sin square x by cos square x into dx. This is equal to this cos square x can write cos x and cos x. Therefore, sin by cos, 1 sin by cos is equal to tan x and 1 by cos is a secant x. Therefore, this is equal to pi integral 0 to pi sin by cos is a tan x 1 by cos secant x dx minus pi integral 0 to pi sin square by cos square is a tan square x dx. And in explain, this is equal to pi integration of tan x secant x is secant x. Therefore, this is equal to secant x, the limit is over 0 to pi minus this pi, and this tan square x can write secant square x minus 1 into dx. This is equal to pi secant x, the limit is over 0 to pi minus pi integration of these two terms. The integration of secant square x is a tan x and the integration of 1 into dx is a x. The limit is over 0 to pi. Now pi common, take outside, and the remaining terms are inside the bracket minus secant x. This minus is multiplied with the two terms, that is we get minus tan x plus x. The limit is over 0 to pi. Now apply the upper limit and then a lower limit. The upper limit is secant pi minus tan pi plus pi. Close the bracket, and lower limit secant 0 minus tan 0 and plus 0 and close it. We know that secant pi is equal to minus 1 and tan pi is equal to 0. Secant 0 is a 1 and tan 0 is equal to 0. Tan 0 equal to 0. Therefore, our value is pi. Our secant pi, the secant pi value is minus 1 and tan pi value is 0 plus pi and close it. Secant 0 is 1, tan 0 plus 0, not necessary to write. Close the bracket. So that is equal to pi. Here minus 1, it is minus 1 plus pi and minus 1. This is equal to pi. Minus 1 is minus 2. Here 1 pi, that is pi minus 2. Pi minus 2. In left hand side is a 2i. 2y is equal to pi into pi minus 2. So therefore our I value is equal to pi by 2 into pi minus 2. Here left hand side 2y is equal to pi into pi minus 2. Our I is equal to pi by 2 into pi minus 2. This is the answer. Actually the answer is pi by 2 into pi minus 2. It is the answer for division number 9 in question number 2. Therefore division number 9 is over. Thank you.